Everyone, welcome to Baozi Training Leetcode solution. If you want the best market email experience in North America, feel free to check us out at baozitraining.org. We're here to help you to get you your next biggest offer. And just if you have any questions in general, feel free to contact us. Meanwhile, feel free to subscribe to our WeChat blog right here. Okay. So today we're going to talk about this problem called the search insert position. Essentially, giving you a sorted array. Here, there's assumed no duplicate in the array. So return the index if the target is not found. Given a sorted array and a target value, return the index if the target is not found. If not, return the index where it would be if it were inserted in the order. Oh, okay. So essentially, because it is no duplicate, so if you find the element, you will just return the element's index. So that's just like the normal binary search. If the index is not found, so just return the position that it will be inserted. Essentially, it's like, so when here, normally when you search for 2, it will return -1, right? Because it's not found. But essentially, instead of return -1, you want to return the position. It will actually need to be inserted, which is in this case 0, 1 should be inserted at 1 position. So if it's at the first element, it will be 0. At the last element, it will be the length of this array. So there's nothing fancy, essentially just a binary search, right? So tweak is just a tweaked version of a binary search. Essentially what we're going to do here is like this. So if this is the case, nothing will be there. It's not a valid case, but so what we'll have is if left is larger than right, normally we'll just return -1. But in this case, so when the left is larger than right, that means you have been searching to a point. So the left point is the one you want to actually return. So think about it both ways. So when you're going right, so your left pointer moves up to the right. So that's the case. So that means you want to insert this element at the left part. So the other part, think about going to the left. You move your right. So you have your left and right, right? You have your like left and right. So now you move left. So that means your right is here and your left is here. So in this case, you also want to return the left, right? Like I said earlier, if you want to move right, so basically it's also like this case, left and right. You also want to return the left. So think about this way. So that will be the case for you. And then so if the target is less than it, so what we want to do is just keep doing searching left. And then in this case, we just want to search right. And else, we just return mid, because that's the only case. Okay. Okay, this is basically the log-n solution for this problem. And one thing I want to point out is what happens if this array actually has duplicate elements. So if it has duplicate elements, so it depends on your requirement, right? So whether you want to, for example, if you have an array like 0, 1, 2, 8, 8, 8, 10. So if you want to insert another 8, so that means if it's 9, it's going to be here for sure, right? Right here. But if it's another 8, so if the element is like, oh, you want to insert it in the beginning or insert it here at the end. So most likely it will be inserted at the end. So basically, it's like right here, if the element here is equal to this element, what you want to do is basically you return target, and then you want to make +1 and the right. So that's all you need to do, because you want to move right part to the 1. So if it's already out of boundary, and then you will just return the boundary part, which is also what you want. Yeah, that's it. So this problem can actually be applied to, for example, the one Uber interview question is like you are at a bus stop, right? So given this API, you can query the time. Basically, all the buses will come to this stop, and then all the time. So essentially, when you're sorting by time, and you want to find which bus will be the next one you arrive. So essentially, you will get the current system time, your current time, and then within this range of all the time, you want to find the first time that is larger than this time, and then that corresponding bus is the next bus that shall arrive. So essentially, doing a log-n search, binary search, the first element is larger than this one, which is that time is the larger than the time than the current system time. So it's essentially you can translate that design problem into this coding problem. Okay, thanks a lot for watching.